working of the ADA boost. So I have taken this example about ADA boost. Okay, we have five rows. Okay, we have five records with us, and uh, uh, we have the outputs. As you can see, yes, yes, no, no, yes. These are the outputs of these instances. Okay, so at the very first step, the ADA boost, it tries to assign a sample weight to all these features. Okay, let me tell you that this sample weight, uh, it is same for all the instances in the very first step. Okay, as you can see, we have the formula thus. We can easily say weight is equals to 1 upon n, where n is the number of the samples. So in the sample weight, uh, we can see that the 1 by 5 it is the sample weight for all the instances. It is same for all the instances. Okay, so this is the very first step. Okay, now in the next step, the ADA boost, it will try to create the base learners based on the features we have. Like as you can see, we have three features. We have feature 1, feature 2, and feature 3 with us. So it will create stumps based on the first feature, the second feature, and the third feature. Okay, it will create the same number of stumps as the number of features. So now, out of these three models, like these three features, these three features we have taken, and we have built three stumps. So among them, the algorithm selects the one. Okay, for selecting a base learner, there are two properties. As you can see that we have Guinea impurity and we have entropy, as you learned about in decision trees. So we can easily calculate these properties. These figures we can easily calculate. So after calculating the Guinea entropy, the stump that has the least value, that is the least value for this Guinea impurity or entropy, we will select that as our first base learner. Okay, so in the figure, as you can see, all the three stumps can be made with the three features. The number below the leaves, these numbers, this 2120 3002, these are the numbers which represents the correctly and the incorrectly classified records. So by using these records, the Gini or entropy index is calculated. The stump that has the least, as I told you, that the stump that has the least Gini impurity or entropy index, they will be treated as a first base learner. Okay. So now, as we have assumed that we have taken the stump one, okay, we assume that the entropy index for the stump one is least, and we have selected stump one. So now on as we have taken this stump, this feature has incorrectly classified the second record. Okay, I am marked that in red. Okay, as you can see, this record is being incorrectly classified by the first stump. So now in the next step, what we will be doing is we will be calculating the total error. Okay, total error. The formula for total error is number of samples classified as wrong upon total number of samples. So as you can see in this table, we have five records, and out of five records, this row number 2 is classified incorrectly. So our total error will become 1 by 5 in our case. Okay, so now in the step 4, what we will be doing, we will be calculating the performance of the stump based on this calculated total error. Okay, the performance of the stump will be calculated with the help of the formula 1 by 2 log to the base of e into 1 minus total error upon total error. Okay, so like this way we can calculate the performance of the stump. Okay, so now you will be thinking that why we are calculating this total error, why we are calculating this performance of the stump. Okay, so if anyone has any idea about why we are calculating this total error or this performance of the stump, they can reply in the chat box. If anyone has any idea why we are doing like this, why we are calculating the total error, why we are calculating the performance of the stump, the basic idea I have already given you in the introduction of ADA Boost. If anyone has any idea, they can reply in the chat box. To know the misclassified instances. Okay. To get a result fast. Um, no, Gohar, that's incorrect. Sanand Lakshmi is somewhere correct. Anyone else want to try? Okay. So let me tell you. Okay, someone else is also for accuracy. Yes, nearly close. But the answer is that we must update. We have, as I told you, that we have to increase the weight for the misclassified samples, and we have to decrease the weights for the correctly classified samples. So that's the main reason behind why we are calculating this total error and the performance of the stump. Okay, because as you know that in boosting only the wrong records on the unclassified records, they got more preference than the correctly classified records. Okay, we are dealing more with the misclassified records, so thus only the wrong records from the decision tree or the stump, they are passed to the another stump. Okay, so we must increase the weight of the wrongly classified records and decrease the weight for the correctly classified records. So in the next step you will be seeing. Yes. So in the next step, you will be seeing that we will be updating the weights of these records like this. Okay. As you can see here, what we have done is we have updated the weights of the incorrectly classifieds with the help of a formula weight into e to the power of performance say. The performance say which we have calculated as I told you. Okay, let me show it to you again. See, from here where we have calculated the total error and then we have calculated the performance of the stump. So from here we got the performance say. We will be using this performance say to update the weights of the incorrectly classified samples and for the correctly classified samples. For incorrectly classified samples, we will be multiplying weight into e to the power of performance say, and for correctly classified samples, we will be doing weight into e to the power of minus performance say. So by this, you can see that the updated weights of the correctly classified samples, they will be decreasing, and the incorrectly classified samples, their weight is increasing. Okay, you can see that for the correctly classified samples, we will get zero point 0.1 as the updated weight. After you perform all this calculation, you will get zero point 0.1 in our data set, and for the misclassified sample, we will be getting 0.399. Okay, so one important thing is that after you update these weights, you need to normalize these weights. As you can see in the sample weight, when we add all the weights together, we will get 1 as the total weight. Okay, but when you add all the updated weights together, you will never get 1. Okay, so to solve this issue, what we do is we normalize the weights. For normalizing the weights, what we will do is we just calculate the sum of the updated weights and divide them with uh, 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 we have to divide our updated weights with the total sum of these updated weights. Okay, you calculate the total sum of the updated weights first, and then you have to divide it by the weight of the each instance. Okay, so you will get normalized weights. Okay, this normalization is very important after updating the weights. So now we have calculated all these things. We have calculated the updated weights. We have transformed that in the normalized weights. So now what? Okay, now what Adaboost does? So now let me tell you that these now the algorithm, it will run 5 iterations to select different records from the older data set. Okay, in each iteration the algorithm will take one random value and select the record whose bucket contains that value. Okay, let me explain this with the help of a pen. Okay, as you can see, these are our normalized weights and these are our buckets. So now what Adaboost will do, it will create the buckets. Okay, 0 to 0.13. Okay, now from 0.13 you add 0.13 and 0.50, you will get 0.63. Okay, so 0.13 to 0.63 is in the bucket of the second record. Then again 0.63 plus 0.13 is 0.76. So now 0.63 and 0.76 is in the bucket of the third record. Okay, so now Adaboost will run 5 iterations and to select the different records. Okay, each time it will generate one random value between 0 to 1. Okay, now let's say in the first iteration the Adaboost has given us a random value of 0.46, let's say. Okay, 0.46. So which record is being selected among these? Please reply in the chat box. Okay, anyone can reply in the chat box. We have got a random value as 0.46. So it is falling in which bucket? On which record it will target? You can reply in the chat box. Point, got 0.1 to 0.63. Okay, I think you are saying 0.13 to 0.63. I guess. Yes, Deepak Panmani, you are correct. Yes, Anant Lakshmi. Yes, okay, go ahead. Okay, so as we can see in our table, which is behind this, you can see that this second record, this is the only misclassified sample. So now in the first iteration, we have got this record only selected. Now in the second iteration, let's say our random value will give 0.53. Again this record is going to be selected. So the as there is a huge amount of numbers that lie in this bucket only, so Adaboost will there is a high probability that this wrong record is selected maximum number of times. Okay, this is all what we need to do only. Okay, let me raise it so you can see it clearly. Okay, so there is a high probability that this wrong record it got selected several number of times. Okay, so now Adaboost will run these iterations, build a new data set taking the records which are selected in each iteration. Now this new data set is a training data for a next weak learner. Okay, it will be passing this data set to the next weak learner. Okay, so as you can see that this misclassified record is targeted the maximum number of times. So most of the times this record is only selected in that data set. So like this way, the Adaboost will be focusing more on the misclassified samples, and at last you will see that the accuracy of the algorithm is improved a lot. Okay, I would request you to please keep your mics off. If anyone has had unmute themselves by mistake, please. Okay, so this is basically how the Adaboost works. Okay, so now how the algorithm it decides the output for the test data. This all we have done for the training data. We have trained the algorithm. Now when you pass the test data, how AdaBoost works with that test data. Okay, so this is the answer. Okay, when you pass the test data to your AdaBoost algorithm which you have trained, okay, while passing your records, it will be passing through all the stumps. Okay, let's say if you have built three stumps, it will be one by one passing through all of these three stumps. And while passing through the first stump, let's say it gives the output as 1. While passing through the second stump gives the output as 1. And while passing to the third stump, it gives the output as 0. Again, wisdom of crowd happens. Okay, majority of votes. The the sample which is getting the majority of the votes, okay, between these stumps, it will be considering that as the final output for the test data. Okay, this is how the output is going to be decided for the test data. Okay, so this is the whole workflow of the AdaBoost algorithm. Okay, from step 1 till step 5. We have discussed all these steps. So I think there will be no problem in understanding these steps. Now we move towards various advantages for the AdaBoost. Okay, AdaBoost has various advantages. As you can see that we have not tweaked parameters more. Okay, at all we have not tweaked parameters at all in while discussing the working. Okay, so it is easier to use with less need for tweaking parameters, unlike algorithms like SVM where you have to set a lot of parameters. Okay, so and the second advantage is that till date there is no concrete proof that AdaBoost is prone to overfitting. Okay, there's a reason behind this, because the reason is that the parameters are not jointly optimized. Stage-wise optimization slows down the learning process. As you have seen, we have doing everything stage-wise. Okay, so there is no chance for overfitting. Okay, AdaBoost it improves the accuracy of your weak classifiers and makes it flexible. Okay, you will be very flexible while using this as a AdaBoost, and even you are getting a very good accuracy. Okay,